Okay, so as I said in our last class, with the science fair happening and Weibo happening on Tuesday, then I have to combine a couple of things together. So with the science fair happening, number one, be patient, be relaxed, wait until I call you in to speak to the judges. Just simply tell them what you had talked about, as I had in the packet. Just be prepared to talk for about 2-3 minutes about what you did, why you did it, and what you found out and how you did it. Okay, so I'll be calling you according to how you're set up to the science lab. It truly is random, and then you'll take your turns, and it'll take a couple hours to get through it. During that time, then you're in your homeroom doing what your homeroom teacher has set up for you and asked you to do. I know Mrs. Ross will have a social studies assignment for you to do, and then I am asking you to watch this video. Make sure you take your notes inside of your book, that you're following along and paying attention, so that you get the true comprehension of the main points of this chapter section, and so that your assignment is a little bit easier to understand. So I already explained to you for chapter 3, lesson 1 on Monday about work and power, and how work is a measurement and power is a measurement. And when I talk about work, I'm talking about doing a force and getting a distance. The force and the distance have to be in the same direction in order for it to be work. The force is if I'm either going to pull something or I'm going to push something, and getting a measurement of that. And the distance I measure in meters, since I'm in science. When I put those together, then we said the label we're going to use for that, for work, is joules. And then when we took a step into power, then we said, well, power then is going to be the work time, or the work divided by the time it takes for it to go. Meaning, I take my force times my distance divided by my time that it takes for it to happen. So when I do that division, then I end up with a label of watts for my power. This section, we're now jumping into chapter 4, because most of chapter 3 is not stuff you need to know as a 6th grader, but chapter 4 takes us into several things that we do need to know. So as you can see, we're not only going to go through chapter 1 today on the video, and you have an assignment, we're going to go through chapter 2, or lesson 2 and 3, Thursday and Friday of this week, and you'll have an assignment over those two that is going to be due on Monday. So we're going to continue to move forward, and we're going to go in a hurry because we've got to get through all of these other topics by the end of the section before the iLearn test. So this first section is about energy, and then we're going to build on the idea of what is energy as we continue through chapter 4. So first we need to start on page 108. On page 108, we're introduced to what energy is, and energy is simply the ability to do work on something that causes a change. Your ability to make a change in something. So I referenced the idea of a backpack the other day. If I'm going to transfer my energy and change it, my backpack is sitting down on the ground. I need to change that and put it onto my back. That energy that's being used is what's stored inside of me. We have talked about, when we talked about food, we talked about sunlight, we talked about food pyramids and food webs. We talked about how in our bodies we have this thing called ATP. It's the energy that keeps us going, that allows our movements to happen. I have to use my energy that's stored inside of me, apply it to the backpack to get it onto my back. That means I'm the energy supply, and the movement is happening to that object so that I can be ready for school. I'm transferring my energy into an inanimate object that doesn't have any stored energy within itself. When I look at my specific types of energies, I have 2 that I'm going to talk about today. Then we'll look at several other types of energies as we get further into this chapter. The first one is the idea of simply movement. Now the book's going to give you some different definitions that are more exaggerated in wording, but just understand that to be kinetic means to be moving. That's all kinetic means. It's energy that shows motion. When I talk about kinetic energy, then I talk about 2 specific things that affect kinetic energy. The speed the item is moving in and the mass of the item. So I give you an example using superheroes once again. If I have 2 individuals running after me and I have to be hit by one, well, in all honesty, it really doesn't matter which one's going to tackle me. If they're both going at 7 miles per hour, they both weigh 190 pounds, it's going to hurt no matter what. If I change that and I have a third person that also weighs 190 pounds, but he's running much faster, that one's going to hurt the most. So speed of an object is going to greatly change my kinetic energy. The more speed I have, the greater kinetic energy that I have. If I have a whole group of people running at the same speed, but there's one that's a whole lot bigger than anyone else, that's the one that's going to hurt the most. The Hulk has more kinetic energy just because of his size compared to all the other individuals after running at the same speed going into this battle. So the larger the item is, the greater the kinetic energy is if they're going at the same speed. But the question might happen then, well, which one affects kinetic energy the most? Well, as you're reading the book, which hopefully you'll do as you're doing your assignment, you'll see that there is one of these two that affects kinetic energy more than the other. Is it mass or is it speed? And that answer is it's speed. Speed is always going to affect the amount of kinetic energy more than the mass of the object itself. The second type is the opposite of moving. So the opposite of kinetic energy, the antonym for kinetic energy, that's potential energy. Potential energy just simply means I'm not moving. Okay? It is stored, it's ready to be used, it's just not happening. We're going to look at two specific types. We're going to look at position and we're going to look at shape. So position is going to be described as gravitational potential energy. Gravitational potential energy, the higher I am, the more gravity I have pulling down on me. When I get to the top of this hill, then I have more potential energy. I'm going slower. It should make sense that I have to slow down my energy as I try to get to the top of the hill. It's going to build, 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 build. I may even have to pause and rest at the top of the hill. Once I start going down, then that potential energy is going to transfer into more kinetic energy, and my kinetic energy is going to rocket to the top. When I have a ball that I'm holding at the top of a platform, it should make sense that I have more potential energy, but gravitational potential energy, because if I let go, gravity is going to pull it down. So when we have something in this held position, that gravitational potential energy is potential. It is stored until I let it go and motion happens. The other kind is then the shape that's going to affect gravitational potential energy. And specifically, we're going to look at elastic potential energy. If I have a rubber band pointed at you, it's not going to hurt you. It kind of freaks us out. We kind of lean back. We may kind of wince and close our eyes. But I can stand there for an hour holding that rubber band, and it's still elastic potential energy. The only way that that becomes painful is when I change it to kinetic by letting go. I wouldn't do that, by the way. Okay. But the idea of the rubber band, the elastic, anything that stretches is that it's going to be stored energy the further back that I pull it. When I get on my trampoline, it is also elastic potential energy. So underneath the blue protective foam rim, there's all of these springs. And these springs, when I push all my weight down into the trampoline, they're going to stretch. Well, their comfort position is to be closed back in. So when I stretch them out, I've got about 40 different springs that are stretched out. Actually, I think it's about 75 of them. But they're going to want to force me back up. The more force that I push going down into the trampoline, the more they stretch apart, the more they want to pull back up. The further down I go, the more they want to pull back up. So potential energy that is elastic means I've changed my shape and it wants to go back to its original shape. When I pull back a rubber band and I let go, it's forcing its energy to go back to its original shape. That also causes it to fly through the air. So let's fill out our book on these three questions and then we'll be done. It's going to be less than a 20-minute video and you can then work on your assignment. The energy an object has due to, should be its motion, not Mitt's motion. Its motion is called blank or blank, kinetic or potential energy. And then the second one is also a definition. Stored energy that results from the position or shape of an object is called blank or blank, kinetic or potential energy. So you simply have to circle which one is true. So hopefully we know now that due to its motion, we're talking about kinetic energy. And when we're talking about its shape or its position, then we're talking about potential energy. Make sure you circle those in your book. For part B, it says, what are the two factors that affect an object's kinetic energy? And we said the two factors that affect the kinetic energy, even though one affects it greater, is its mass and its speed. Remember, speed is going to have a greater effect on that kinetic energy than mass does every single time. And then the last one is, what type of energy does a cup sitting on a table have and why? So being able to explain why is important to this. Well, if it's just sitting on a table, it's not doing anything. But a table's high up off the ground. So if it's high up off the ground, then I know that that has to be a potential energy. It's just sitting there, it's not moving. The why part is because it's not moving. Right? So potential because it's just sitting on the table. And then I put under here, not moving equals no kinetic energy. All right, so that's it. It really is a pretty easy and simple lesson. It was designed to give you some extra time to get that assignment done and started in class. Since we're at Western Boone, I have to do it by a video. But make sure that you have this filled out and then get started on your assignment. Once again, it is 2 sides. Make sure you do both sides, and then it's ready to be turned in come Thursday morning.